All right, so we talked about that an identity is an equation where it's always true. And so if we wanted to verify that something was an identity, you know, one thought is, well, I could plug something in and see if it works. So to prove that it's an identity or show that it is, we could plug in to both sides of the equation. So what if we had the value pi over 6 and we plug that in to each of the values? So secant of pi over 6, and then we have minus cosine of pi over 6. And on the other side of the equation, I have sine, and I have tangent. And if I look, pi over 6. And if I look at my unit circle, pi over 6 is at the point. So pi over 6 has the point square root of 3 over 2, comma 1/2. So cosine is square root of 3 over 2. Secant would be 1 over that. So it'd be 2 over the square root of 3 minus square root of 3 over 2. Sine would be the 1/2. Tangent would be y divided by x. So end up with 1 over the square root of 3 because the 2's would cancel. Now you say, okay, those don't equal each other. Well, let's see what we can do. Well, I can multiply, get the same denominator, multiply by square root of 3, multiply this one by 2, and I get 4 over 2 square root of 3 minus square root of 9, which is 3 over 2 square root of 3, get 1 over 2 square root of 3. And over here, when I multiply them together, I get 1 on top and 2 square root of 3 on the bottom. Well, that shows that it's equal. But is that really enough to say that it would be equal no matter what? It's not. So what we need to do to prove something is to do it without plugging in values. Because this only proved that it was true at pi over 6. What we can do is we could rearrange to show that the left side is equivalent to the right side. Now you could work just on the left side. You could work just on the right side. You could actually work on both sides until you get them equivalent. So I'm going to draw a line down my equal side. I'm not going to cross the line, but I want to make both sides match. So secant is 1 over cosine and minus cosine. I'll put that over 1. And I'm trying to make that equal sine theta times sine over cosine. Well, I'll make that over 1. Let's see. Okay, let's start on this side. I'm going to make this have the same denominator. So I end up with 1 minus cosine times cosine. So 1 minus cosine squared over cosine. And on this side I have sine times sine is sine squared over cosine. Oh, wait, 1 minus cosine squared is sine squared. They match. Check. Cosine, so I'm going to draw a little, okay. Cosine divided by sine times, cotangent is cosine over sine. Now I could just work on this side for a little while if I wanted, because I noticed that the sines are going to cancel. And now I've got cosine divided by cosine, which is just a 1. Okay, well, let's see if we get that over here. Secant is 1 over cosine times cosine. Well, that's just 1. It matches. Let's try some harder ones. Okay. Ooh. Let's see. There is nothing I can really do to that right side. So I'm just going to have to work on this left side. So I'm going to distribute. So that's 1 over cosine times 1 over sine minus 1 over cosine times cosine over sine times cosine. Okay, let's see. Well, I get over here 1 over cosine times sine. Minus. Now, my first thought was to cancel these out, but notice that in the denominator, I'm going to have cosine times sine, so I might as well not cancel anything out, so my denominators match. I have 1 times cosine, that's cosine squared. 1 minus cosine squared over cosine times sine. Still doesn't match. 1 minus cosine squared. Ooh, sine squared. All right. Well, sine is going to cancel out with one of the signs there and leave me with sine theta over cosine theta. Hey, that's what tangent is. Yay. 1 over sine theta minus sine theta cosine theta times cosine theta over sine. Okay, they definitely do not match right now. But I'm going to make this side combine. So I'll have 1 over sine theta minus sine squared over sine theta. That's 1 minus sine squared over sine theta. Oh, cosine squared theta over sine. That matches. Sine theta divided by 1 over sine theta plus cosine theta over 1 over cosine theta. Equals secant squared. That'd be 1 over cosine squared minus sine squared over cosine squared. Well, over here, if I multiply by the reciprocal, that'd be sine theta times sine theta over 1. And then I'd have cosine theta times cosine theta over 1, which gives me sine squared plus cosine squared, which is 1. All right, denominators match, so I'm going to combine the numerators. Well, 1 minus sine squared is cosine squared. They match. Sine squared plus cosine squared is 1. So I have 1 over sine x over cosine x. Over here, I have cosine x over sine. So 1 times the reciprocal, cosine x over sine x, and they match. So I actually find these easier because you know where you're trying to get to.